And the next speaker is Professor Jagadish Shukla from George Mason University in the United States.
You have something to screen?
Yes, I need to show here. Just can
You have it already here?
Yeah. Let's
Okay.
see. Oops, this one. Can you put that on?
That's one. And you have it here.
Okay.
Okay. Forward, backward.
This is forward and backward. Okay, I can talk. Okay. Well, thank you very much. I should really thank Mira and Elena for inviting me. This is such an incredible opportunity. This is my first trip here. And when I was invited by Mira, my first reaction is I don't work on Dead Sea research or living or aging. So then soon I found out that if Mira invites you, you just come. You don't ask any questions, okay? So that everybody knows. It took me some time, okay? Actually, I was feeling very lonely in the daytime because the word climate I saw on your slide in the morning. After that, okay, right. So whenever I'm speaking in an audience where climate is not the topic, I actually take the liberty to spend a few minutes just to say, what is climate? And it may sound like an unnecessary thing to talk about it, but coming from where I come from, the United States, where there's always a question about is climate science is known, is not known, it is false, it is hoax, it is whatever it is. I just really thought I'll just spend 2 minutes because that will set the stage also for what I'm going to do. So I actually use a very simple example to, let's see, is that, yeah. So if you take the global surface mean temperature now, average over the year and average over 100 years, you will get a number. It's 15 degrees centigrade, okay? Why it is 15 degrees centigrade? If we know the answer of that question, then we basically know what is climate. And what I found out while teaching my climate course and so on, that most of the students actually don't know the answer of that question. So I'll just give you one sort of 30-second explanation. While Earth is heating, and we only heat that part of the Earth which is facing the sun, Earth is radiating energy all the time, 24 hours a day. And it is the equilibrium between these two energies that defines the climate. And because the energy that we are releasing is a function of temperature. So you can imagine if you keep warming up, there will be a temperature at which the both energy will be equal. That temperature is called climate. That temperature is 15 degrees for Earth. That temperature is 500 degrees, 600 degrees for Venus. So we understand that. And the reason I wanted to give this quick introduction is because that concept of the equilibrium between the incoming energy and outgoing energy fundamentally explains all the questions that are being raised. By the way, I ask students why it gets cold at night. They all raise their hands. Say, why? They say, oh, the sun sets. Then I tell them you'll get a B- for that answer, because that's not the answer. Unless you know the fact that you are radiating energy, it is equilibrium. Why you get seasons? I don't know how many of you have watched this Harvard video. Some guy went with a video camera and interviewed all the Harvard graduates recently and asked them why there is winter season and summer season. And almost all of them said, during the winter season, Earth is farther away from sun. And during the summer season, it is closer. Totally wrong answer. It's just the opposite of the answer. It's not winter season is colder because Earth is farther away from the sun. It's because of the tilt of the axis of the Earth. That is what gives us, you see, winter and summer temperatures we can explain. Ice ages. We have a very simple explanation. Many people say, oh, climate is all the time changing. We had ice ages, so therefore what's different now? Well, we know why ice ages came, because the total amount of energy coming from the sun was different. Not because sun was different, but just because of the eccentricity was different of the Earth, or the tilt was different, or the precision was different. So, and this is why we also know the climate of the planet. The Venus is so much warmer than us. So please, just remember that the science of climate is just so well understood. And now really the question is, how do we predict? and what are the questions predicting, and I will give you a few, some slides. So coming to the title of my talk, if you look at the history of the global, sort of the temperature of the Earth, and this is about the best record we have, for 10,000 years, we had a steady climate. Well, that's how the human civilization grew. After all, agriculture was discovered 8,000 years ago. Okay, we have, and of course you can see what is going on in this. And the question we are asking now is that, okay, what is happening now? And that was really the title of my talk. Well, we know what is happening now. Population is increasing at a rate which is just unbelievable. Carbon dioxide that we are releasing is increasing at a rate which is just unbelievable. If you look at the GDP, is increasing exponentially. And here's the thing, the population is increasing and GDP per capita is increasing. So the impact is a product of both, per capita GDP and the population. Imagine how fast it is increasing. So actually, if you look at, and again, I will not go into any of the details, but look at the impacts that human activities are having all the way. The physical climate system, we understand, with floods, droughts, biodiversity, the loss of the ecosystem, inequality and social conflict. It is actually something, by the way, one of the reasons I really like to come to talk about, I was told interdisciplinarity is really the theme of it. Well, here we're talking about a very global interdisciplinarity. We're talking about social issues, we're talking about climate scientific issues, we're talking about issues of equity, we're talking about violence and conflicts. There are going to be a huge impact of climate on violence and conflict, local, and you can trace down the Syrian war to many of the problems that happened with the droughts. So that is why I chose this title, that, okay, one of the climate scientists gave this name, Anthropocene, and of course geologists have not yet accepted it, but they're debating it. You know, maybe they will accept someday. So what are the challenges? And I have put my lecture, by the way, I have to first apologize. I planned a 60-minute talk, so obviously there are a lot of slides I will have to skip. So please, and please give me a few minutes, because I would rather have a discussion rather than take all my time. So give me several more than a couple of minutes, okay? So this is what we are. So just want to make sure that we understand that we do have a civilization in our planet. It is because of the greenhouse effect. If there was no greenhouse effect, we will not have it. It is because of the balance. It is just that this too much of a good thing is not good. And that is what we are doing with increasing the CO2. So I would like to go to the next topic, which is, okay, so what is the science of climate prediction, what we are doing? So far as observations is concerned, you must have seen this in newspapers all the time, so therefore I don't even have to see. People say, oh, the temperature is going up and down. No, it's not going up and down. It's just warming. Constantly it is warming. There isn't, I mean, there are some fluctuations, and we understand it is the interaction between the atmosphere and ocean, interaction between the land and the atmosphere and ocean, which produces fluctuations. But the trend, unless you belong to a particular group in Washington, it is actually clearly warming, and it is human-induced. That's not really the problem. So then you must ask, this is what it asks, so what's different now? If Ice Age is the temperature was changing, now the temperature is, what is different? Please remember this one very simple thing. It's not the temperature, it's the rate of warming. It's the rate of change. It is almost 100 times faster than ever observed before, both the increase of the CO2. So that's a big difference. So people who don't want to believe in climate change, they just simply, oh, things are always changing, what's different now? It is big difference. And you will hear the word natural variability all the time. Believe me, natural variability is always used by the people who don't know what is natural variability. Natural variability is the dynamics of the atmosphere and ocean. We understand that. There are hundreds of departments in the world which are teaching natural variability. We understand that. That's not climate change. And the climate change is actually much easier to predict than weather, because that's one of the things that we ask. Why? And by the way, my main day job is really predictability of weather and climate. And Lorange was my professor, and I know all about chaos theory, and all my research has been predictability in the midst of chaos. How within a chaotic system, there are very predictable components. And the reason is very simple to understand why climate change is much more predictable. If you are a pool player, okay, on a pool table, you hit one ball, and try to predict the second ball and the third ball and the fourth ball. You will not predict much, no matter whatever expert in the world you are. But that's chaos. Think of that as a chaos. But suppose somebody came and lifted the pool table from one side, 100% prediction, where all the balls are going to go, right? Exactly that is what the climate change does. We are basically lifting the pool table. By injecting CO2 in the atmosphere, what we are doing is a external forcing. So this is another question, the myth that, oh, climate is not predictable. Climate is far more predictable than weather. Weather does have, because if you know the external forcing. Of course, if you don't know the external forcing, then it's not unpredictable. That's why we have uncertainty. We don't know how much humans will create in the next 100 years, 200 years. So that's where the uncertainty comes, not because of the physics. Okay, so I will not show you any observed changes. You have seen this all. Globally definitely warming. Look, sea ice is decreasing. I mean, just unbelievable the amount of sea ice that is decreasing. Salinity is actually, it's getting acidic. The ocean is getting acidic. You are concerned with a lot of things I heard today about the Dead Sea. The global ocean, and this is going to be a major disaster for the phytoplankton and the sustainability of the ocean. So I think I'll just like 1 minute, because the essence of all our climate research is climate prediction. How do you do it? Well, this is one of the major advances of our field in the last 50 years, let me tell you, that we now have mathematical models based on Newton's second law of thermodynamics, based on laws of physics, where we actually write down actual equations for rate of change of momentum, rate of change of velocity, rate of change of moisture. And we divide the globe into about, let's say, 10 million different grid points. And on each one of them, we have like 10 equations. So you have 100 million equations. And you basically take a supercomputer and you know today's temperature, pressure, and then you calculate what will happen after 3 minutes. And then 3 minutes later. So this entire weather and climate modeling is done by integrating these 100 million equations 3 minutes at a time. So when you see on TV, by the way, these are the equations that produce weather forecast. So when you see weather on the TV, it is product of a supercomputer where the global system was integrated 3 minutes at a time. But people don't want to know what happens every 3 minutes. You cannot convey the data, so you get it after 24 hours or 48 hours and so on. This is a major, major advancement. And there are many models in the world, and that was a challenge that was given to them. That what is it possible that the human activities are actually affecting climate? You can hand wave and say, oh yeah, CO2 is increasing, and so we know from physics and chemistry the CO2 increases heating. But then another person can wave their hand and say, no, it doesn't happen that way. What will you do? That is why there are about several thousand scientists, 20 countries, they are building these models. And those are the models that are at the heart of the entire climate change debate. And if you look at the factors that will change climate, so I've told you, if you look at global mean, ocean and atmosphere, they're all averaged out. So what is left? Either human cause increases, a sun, solar, or volcanoes. By the way, these are the only truly external forcings. Look at the numbers. The sun in the last 100 years, more than 100 years, is just almost negligible. Because it goes up and down every 11 years, but it has no tendency. It has no impact on 100 years. Human-induced is the biggest region that we have. And this is the prediction for, say, 100 years from now. I mean, you can already see from observations, and I skipped the observations because of the time, that the polar regions are warming much faster than the... Now, here is the topic that I thought I was going to talk for the first time when I did extreme events. So in climate change, if it was a global mean temperature is going to change by 1 degree or 2 degrees, who will care for the global mean temperature? We don't live in global mean temperature. The climate change manifests itself by extreme events. And it is the society perceives them through the extreme events. And it is in some way, that is the challenge that we have now, to be able to try to figure out how to predict. And we cannot predict individual event, there's just because chaos theory comes into the picture, but you can predict the probability distribution function shifts into the event. And that is what the biggest challenge is that is going on. So the predictions are that the sea ice is going to collapse almost completely. Look at that. So, this is the first part is what is happening now. Same thing with ocean sea level. It is going to go up. It's going to go up. And now, unfortunately, it is increasing, accelerating the rate at which the sea level is going up. So in order to get these questions, 13 countries were asked, and each country has one or two models, and about 39 models were run to be able to answer this question because it is of such an important for society. And this is their conclusion. All climate models. So when you hear in the American media, there is a divided opinion, you don't know where the divided opinion is coming from. All the climate models of the world, not all the countries. So unless the governments are all over the world are in a grand conspiracy to, let's say, global warming is going to happen, this is the result. So now, what is the challenge? So I'll tell you what was the theme of my lecture was that, okay, we want sustainability. We want both social sustainability, environmental sustainability, and economic sustainability. That's how we can have a sustainable future of this, okay? We have to have all three of them. So we have some big challenges. And I will just mention to them, just very quickly, each one of them. The scientific challenge is very simple. We really need to go from climate models to Earth system models to human system models. I'll tell you what I mean by that. By the way, this is the history of climate models. It's a huge progress that we have done. But this is what is happening now. We have the dynamics of the system, and we have all the external forcings, and we have to calculate the influence of earthquakes, volcanoes, sun. Earthquakes don't affect climate, but they do have other effects on the side. So this is what has been happening till now, and this is what the challenge is. And by the way, there was a question about interdisciplinarity. I will end up by making a suggestion that we really need new kind of institutions. I tell you why. Till now, the climate models, the Earth system models, we tell them, this is what will happen. Global warming will be so much, sea level will rise so much, And the policymakers take that, then we go to the human systems, and then say, okay, this is what we're going to do to society. That has to change. We must have interactive Earth system and human system models. This is something that is absolutely missing right now, and this is something which I'm going to make in the end. Ethical challenges are really, really serious. I mean, look at the people who have contributed the least are going to suffer the most. That's all I'll say. I mean, imagine if something happens to the Tibetan, sort of the Himalayan. Imagine what immense population of the world depends upon the river runoff and the agriculture of that. If you look at the impacts, the countries which are poor are the ones that are going to hurt more. They're going to get much more hurt because of their increase in the GDP. And now the political challenge, this is actually an American phenomena, okay? So I'm just doing it as a comic interlude, okay? Just think of it as a comic interlude. Nowhere in the world, the faith in the global warming depends upon which party you belong to, if you're okay. And I mean, this is, if you look at this is 2016. I made this slide in 2016, end of 15. And imagine this person is praying, God, please come and change something in this world because this is very difficult, very difficult civilization. So we're praying. What do we got? Okay, so I just want to tell you that this is how our prayers were answered. And now we just have to just work harder to this. Why it is a challenge, international challenge? Every country wants to increase the quality of life of their people, right? I mean, look at the per capita CO2 emission directly related to the Human Development Index. You go to international meeting, India's Prime Minister comes and says, I want to improve the quality of life of my people. You know, I'm releasing only a few tons, 1 or 2 tons per capita. And USA, you are releasing 18 tons per capita. How do you do? Do you see the dilemma? Do you see how do you have an international, because Human Development Index, by the way, is a very good measure of society. It's just based on many things. And other international problem, look at the who is releasing it. So I think that since I've been given a notice, I would really like to end with some kind of a positive outcome, positive conclusion. Hey, this is a solvable problem. Okay? We know the properties of CO2 molecule. We understand. We have a young generations who are studying. We know the property, we know the science, we know the technology. And the only question is, how do we adopt the pathways that will bring it down the temperature to 2 degrees. By the way, the reason 2 degrees was given by Paris conference is because we know last time it was 2 degrees, sea level was 6 meters high. But at the Paris conference, we decided, no, let's change it to 1.5 degrees, which is more of a challenge. But this is what you needed to do. So I think that the challenges are there. I just wanted to summarize that there is no controversy about science. It is absolutely clear that it is real, unequivocal, human-induced. That's the result of the science, okay? But in order to be able to have a sustainable and equitable development, the world has to come together. And I think it's a solvable problem. And the last item is for Mira. She likes to create institutions, all right? Well, guess what? We have a challenge of creating new institutions where the Earth system models and the human system models can interact, because then only we can make better prediction. Thank you very much, sir.
I just want to say something that I was planning to tell you at the end. First of all, now everybody understands why I insisted on you. And second is let's do something, because it's exactly why we are here the 2 days and a half about. Just let's come up, and we have the last session of joint collaboration. I think this is a moral and a right and a world mission. Take the lead. We are with you.
Thank you.
Okay, thank you. And on this optimistic note, let me ask you for questions.
Really, I join Mira. Thank you very, very much. And now I understand why 30 years ago was it that you insisted on establishing COLA,
Yes,
which
yes.
is the center.
Yeah, by the way, I met him in Maryland 25 years ago. Yeah.
Yes.
Yeah.
Not a drink.
It's called Center for Ocean Land Atmosphere.
Exactly. So the thing was burning with you already that many years ago, that the effect of the human being on the climate
Yes.
is much larger than we used to assume.
Yes. And by the way, he reminds me, because he and I used to work on impact of land. I mentioned CO2 emissions. What I forgot to mention is deforestation and change into the cutting of the trees is almost 30% of the problem.
I just want to add one more thing regarding the whole 2.5 days, that at the last day we have another, we can combine to that, and Jonathan is here, where is he? The supply chain as well.
Yes.
It all is combined.
Yes.
And if I may even dream higher, our quality of life from young, very young, to the aging. So if we can, and if we can combine more and relate to more, I think that should be the right place to do that.
Thank you. Jonathan has his hands up.
A short question. And the last one.
I believe that you said that the mean global temperature was 15 degrees C.
Sorry?
I believe that you said that the mean global temperature
Yes, the global surface temperature of the Earth.
Right, it's 15 degrees C.
100 years ago, it used to be 14 degrees.
I understand that. I had an argument with someone about climate change, and they asked me a question, I couldn't answer it. And the question was, 15 degrees? How do you know that? There are places on the Earth where the density of thermometers is very low, and 200 years ago it was lower, and 1,000 years ago it was zero. So what would have been the right thing?
That was a question 30 years ago, 40 years ago. It was very common. People who didn't want to believe in it, they said, how do we know? We have so much of satellite data. We have so much of ocean SIP data. We have so much of surface data. And we have such good models which know how to interpolate where data is not there. So this is absolutely nobody actually doubts that.
Okay, what about the temperatures that we're giving 200 or 300 years ago where we didn't have these satellites? Believe me, I believe what you're telling me. I just want to know what to say to other people.
Oh, no, 200 years ago, of course, it is indirect measurements, but there's no doubt about what has happened in the last 150 years. We have got pretty good, and there are about 10 different panels of National Academy of Sciences in USA, which has come out one after the other. And if I can tell you just one simple anecdote, 35 years ago, 40 years ago, when the Mauna Loa Observatory started measuring CO2 and it started showing that the CO2 is increasing, people who didn't want to believe in it, you know what they said? It is because the observatory is located at a tourist spot and all the parking in the parking lot of all the people who are driving is causing it. And then it turns out that after 3-4 years, it turned out it was also increasing at South Pole. And it was also increasing on North Pole, so parking could not be explanation.
Too many snowmobiles, thank you.
Yeah. So there is no limit to which people will question if they don't want to believe. And if I can just say this, there are two kinds of blind people, one who cannot see and one who do not want to see.
Okay, thank you. Thanks for this nice talk, and let's switch. Thank you.
Oh, thank you. Thank you very much. Thank you.
And let's switch to the next one.